Welcome back, students. I am Sir Sunil, your physics teacher. Good morning to one and all. How are you all? I hope you all are fine. Okay. Are you enjoying the holidays? Okay. Okay, all are enjoying. Here, today we are going to discuss our second unit, physical quantities and measurement. From this chapter, we are going to take to discuss today one important topic, that is the unit of relative density. All of you please take out your book and watch this session carefully. Okay, students, here is our topic, relative density, the unit of relative density. Actually, relative density is just a number. It has no unit. It is a dimensionless quantity. It is a ratio of same quantities. It is just a number. It has no unit. Okay, students, you understood, no? Relative density, there is no unit for it. Now we are going to discuss about the measurement of relative density of a liquid. The measurement of relative density of a liquid. The relative density of a liquid is measured by using a density bottle. Yesterday we have discussed. It is measured by using a density bottle. This can be understood by the following activity. Here we can discuss, we are going to discuss the activity number 5 from our chapter. Clear? To determine the relative density of a liquid using a density bottle. Okay. The activity here, first we have to do for, take an empty dry density bottle. First we have to take an empty dry density bottle. Find its mass m1 gram by using a beam balance. By using a beam balance, we have to find its mass, that is m1 gram. Now fill the bottle completely with water and insert the stopper. The extra water overflows through the hole in the stopper. Dry the outer surface with a blotting paper and then measure the mass of bottle again on a beam balance. First of all, we have already weighed it without water, empty bottle. The mass, it is m1 gram, and later we have filled the water in it now, and again we are going to weigh it and we will get the mass m2 gram. Okay. Now empty the bottle and dry it. Fill the bottle again completely with the given liquid and insert the stopper. Again, the extra liquid, if any, will overflow through the hole in the stopper. Dry and measure the mass of bottle again. Suppose the mass now is m3 gram. Okay, m3 gram. Now we got first empty bottle, that is m1, then with the water, that is m2. Now we got third mass, that is m3. Okay, students, m1, m2 and m3 now. Thus, mass of empty bottle, that is m1 gram, mass of bottle plus water, that is m2 gram, mass of bottle plus the given liquid, that is m3 gram, m1, m2 and m3. Now how to find out the mass of water? That can be found out by using the relation m2 minus m1 gram. M2 we know, M2 how much it is? M1 also we know, that minus it, M2 minus M1 gram. Then we'll get the mass of water. Okay. Now we are going to find out the mass of liquid. That can be found out by using the relation M3 minus M1 gram. Okay, M3 minus M1 gram. By using the relation M3 minus M1, we can find out the mass of liquid. Okay, students. Now what to do? Find out the relative density of liquid. Okay, find out the relative density of liquid. That can be found out by the relation mass of liquid divided by mass of equal volume of water. Mass of liquid divided by mass of equal volume of water. The relative density of a liquid can be found out by this relation. We know that what is mass of liquid? That is M3 minus M1, that is M3 minus M1, and mass of equal volume of water, that is M2 minus M1. Okay, we will get now M3 minus M1 divided by M2 minus M1. Okay, M3 minus M1 divided by M2 minus M1. Okay, for example, here an example is given. Suppose we are going to take M1 is equal to 25 gram, M2 is equal to 55 gram, M3 is equal to 49 gram. Then what is relative density here? That is 49, that is M3, M3 minus M1 gram divided by M2 minus M1 gram. That means 49 minus 25 gram divided by 55 minus 25 gram. Okay, by doing the calculation, we will get the answer. Here the numerator part 24 and denominator part 30, means 24 upon 30. We will get the final answer 0.8. There is no unit. Okay, students, understood? If you have any doubt, you can ask to me directly when the class starts. Okay. So now here is an interesting fact. Always we are getting some interesting fact in our physics book. Do you know part? Okay. Here, first one, density bottle measures the density of a liquid. Density bottle measures the density of a liquid. Since density of water is 1 gram per centimeter cube, so density of a substance in gram per centimeter cube, that is equal to relative density of the substance. And also, since density of water is 1000 kilogram per meter cube, so density of a substance in kilogram per meter cube, that is equal to 1000 into relative density of that substance. Fourth point, specific gravity usually means relative density with respect to water. Specific gravity usually means relative density with respect to water. Okay, students. Now we are going to discuss the point relative density of a substance in its different states. Relative density, density of a substance in its different states. A substance can exist in how many states? We have discussed in first chapter. How many states? Solid, liquid and gas, means in 3 states. In 3 states a substance can exist. Those are solid, liquid and gas. For example, again water comes, okay, we know the example of water, okay, ice, water and steam, okay, same example. Ice, water and steam are the three states of same substance, that is water. Water can exist in three states: ice, water and steam. We know this point, many times we heard. According to the molecular model, we have read that the molecules of a solid are closely packed. The molecules of a solid are closely packed and molecules of a liquid are loosely packed, while those of a gas are very loosely packed. Therefore, a substance is highly dense in solid state and less dense in liquid state. Okay, students? And still less in gaseous state. Thus, the density of a substance in solid state is more than that in liquid state. You please underline this point. The density of a substance in solid state is more than that in liquid state, and density of a substance in liquid state is more than that in gaseous state. Okay, understood now? The density of a substance in solid state is more than that in liquid state. Okay, sorry students. And density of a substance in liquid state is more than that in gaseous state. One exception is there. Okay, the density of ice is less than water. The density of ice is less than water. I told you here the point. The density of a substance in solid state is more than that in liquid state. That is our theory. But here one exception. The density of ice is less than water. The density of ice is 0.917 gram per centimeter cube. That of water is 1 gram per centimeter cube. The density of ice is 0.917 gram per centimeter cube, but the density of water that is in liquid form, that is 1.00 gram per centimeter cube, and that of steam is 0.00057 gram per centimeter cube. Okay students, this is the exception for water. The table above also gives the density and relative density of some common substances. You please observe it. Okay students, here is our table. Okay, density and relative density of some common substances. Okay, please go through it. In solid state, many examples are there: cork, wood, ice, glass, aluminium, iron, brass, silver, lead, etc. Liquid state, turpentine oil, alcohol, water, milk, glycerin, mercury, etc. Okay students, you have gone through the table. Okay, many substances, examples you have seen. Now we are going to discuss about floating and sinking. If you place a piece of cork and an iron nail on the surface of water, we notice that the cork floats while the nail sinks. The cork floats while the nail sinks. Why? Why nail sinks there? The density of cork is less than the density of water. That's why. The density of cork is less than the density of water. That's why the cork floats. while the density of iron, that is more than the density of water. Thus, a body floats on a liquid if its density is less than the density of the liquid, while a body sinks in a liquid if its density is more than the density of the liquid. Clear? We can conclude that a body floats on a liquid if its density is less than the density of liquid, while a body sinks in a liquid if its density is more than the density of liquid. Some examples are given here. Okay, we can discuss some examples here. A solid iron ball with a density of 7.86 gram per centimeter cube will sink in water, which has a density of 1.0 gram per centimeter cube. But the same iron ball will float in mercury. The same iron ball will float in mercury, which has a density of 13.6 gram per centimeter cube. Okay, students, this point I had to listen carefully. A solid iron ball. In both situations, we are taking a solid iron ball. Its density is 7.86 gram per centimeter cube. It will sink in water because the density of water, that is 1 gram per centimeter cube. Okay, both density you see, the density of water, that is less. Okay, the density of iron ball, that is more. Okay, that is more. That's why the iron ball sinks in water. But same time, okay, same time, we can see here the same iron ball will float in mercury. Clear? The density of mercury, that is 13.6 gram per centimeter cube. Same time, the density of water, that is 7.86 gram per centimeter cube. Which one is more? The density of mercury. That's why this same iron ball will float on mercury. Okay, students. Now, next example, a small cork will float on water because the density of cork is less than the water. Okay. Whereas an iron nail will sink in water because the density of iron nail is more than the density of water. Cork will float because the density of water is more than that of cork. But an iron nail will sink in water because the density of iron nail is more than the density of water. Okay, you understood now how the body will float or sinks in the respective liquids. That is due to the densities, whether it is more or less. Okay, students. Now we are going to discuss about the principle of flotation. The principle of flotation. Okay, students, it's a time to wind up the class. Okay, I hope you all understood today's points. Okay, if you have any doubt, I am with you. You can ask to me when the class starts directly. Okay. Okay, today I am going to wind up the session. Goodbye and have a nice day. Thank you, students.